Hi, my name is John Wilson with Motor Diagnostic Systems. Today we're going to show you an introduction to the Motor Analyzer 2 from Schleich. What you see on the screen is the small little portable MA2 and a small little stator that we're going to test. To turn on the MA2, you just come over here and turn the key to the on position. It is a battery powered instrument. We can hook up AC if we'd like, and I'll just do that and turn it on. And there we have our MA2 up and running. You can see there's a message on the screen when it boots up asking us to make sure that we're connecting a motor that is not energized. If we did, we'd have quite a mess. Backing up, looking at the available controls and the test leads. Here we have our display, obviously. We have a set of soft keys here, a whiz wheel for entering and selecting options, the on-off button or on-off switch, key switch, and then the test button that you see down over here in the left-hand corner. There are 8 test leads total, 2 for lead 1, 2 for lead 2, and 2 for lead 3. The yellow one here is a ground, and the red one is a separate dedicated 6 kV DC high pot test cable. So let's connect our stator over here. Here is lead 1 going to phase A of the stator, lead 2 to phase B, lead 3 to phase C, and our yellow ground. And with that, we have our stator connected. Next, let's enter some information about this stator, and we'll tell the instrument how we want it to test. So let me zoom in on the screen here so you can see what I'm doing. So using the whiz wheel, I will move down over here to the option that says Enter Motor Data. Here we have 4 fields, a job number, a customer, a location, and a note field. So let's use the whiz wheel to edit these things. I'm going to change my job number from job 4 to job 5. So I'll use the whiz wheel, select the center, and I'll come over here and use the delete key, and I will change add a 5. There we go. Now that we have our motor data entered, let's select the test mode that we want to use. Since we have a 3-phase AC motor, let's choose the 3-phase AC motor option. This particular small motor is actually a 480 volt motor. Let's select by setting this value here to 480, the unit will automatically calculate the proper test voltages for this motor. Now the only thing left to do is do the test. Now that we have our test modes defined, let's go and look at the auto test screen. Here we have the test that we're going to perform. We'll have a resistance test. We've disabled some inductance and impedance tests. We've also disabled a capacitance test, and we'll jump right into an insulation resistance test at 500 volts. Then we'll step into a surge test. So when we press the start button, it's going to automatically go through all these tests that we have enabled. So let's just do that. Press the start button. If we back out, we can see over here on the test leads we have LEDs illuminated in front of each test lead that's active. So we saw a moment ago it did the resistance test. Now it's doing a DC megohm test. Let's zoom in on the screen so you can see that. Here we have our 3 resistances that we measured, and we've jumped right into an insulation resistance test. This is a 60-second test per IEEE 43, At the end of this, it will acquire the insulation resistance and have that available to save. When it's done with this test, it'll step right on into a surge test. This surge test takes a little bit of explaining, so while we're waiting for the megohm test to finish, I'll start. We'll start at 500 volts with the surge test and apply 3 pulses, one between leads 1 and 2, a second one between 2 and 3, and a third one between 3 and 1. And then we'll calculate the error area ratio on a pulse-to-pulse type basis, or a peak-to-peak type basis. And there we go. So we finished with our megohm test, started at 500, 525, on up. You can see it going up there. If we back up a little bit, we can see the quite a bit of activity on those test leads. Again, we're going to take 3 surge tests at a given voltage on all 3 leads, and then we'll increase the voltage. Now this is different than the way most surge testers have worked in the past, but the guys found that this is really a very effective way to test an assembled motor. Now the EAR numbers that you see down here are pulse-to-pulse EAR numbers. So we'll compare, say, the test at 1200 volts to the test at 1225 volts for just lead 1 to 2. If there is an arcing fault, these numbers are going to jump up very high, and it'll be very obvious. So once this is finished, we'll actually go take a look at the waveforms. Since we have the peak-to-peak EAR here, we really don't need to see the waveforms, but we're all used to looking at them, but we'll go look at those here in a minute. So I finished the test, everything's good. Before we move off this screen, let's save the data. This button here will save the data to the internal memory of the tester. And there it is, it's saved. We'll leave this screen and go look at our surge waveforms. So there are the 3 waveforms at our final test voltage of 2000 volts, and we can see we have 3 waveforms basically all on top of each other, and that's a good thing. If we had had a arcing turn-to-turn fault, we'd have seen one of them shifted, and this bar graph of the EAR values, one of them would have jumped up quite high. Here on this screen, we can also run a manual test. If I press the test button here, it's going to repeat the test that we just saw run automatically. It's starting out at 500 volts, increasing at 25 volt increments. And we're doing a peak-to-peak or a pulse-to-pulse error area ratio. Again, I've got to emphasize that this instrument runs differently than almost any other tester you've ever seen. You can see the test leads there are pretty active. Let's make it so you can see it. So you'll see it do a 1 to 2, a 2 to 3, and then a 3 to 1. It takes each one of those waveforms and plots them on the screen, and then calculates a peak-to-peak or pulse-to-pulse error area ratio. If we ever need to stop the test, we press the start-stop button and off it goes. So we've tested an assembled motor. Let's test a stator. So over here on the left side, you can see I've replaced our motor with a small stator. Over here on the screen, let's zoom in and I'll show you the settings for testing a stator. The upper left-hand corner, let's enter this select the test mode item, and we'll move this thing, the whiz wheel, over to select the AC stator 3-phase. Again, it will ask us for a voltage. This is a 480 volt stator. Select that. Select the auto test. And again, it's queued up the test that we're going to run. To start the test, we'll press the start-stop button. There we go. So now we're running the resistance test. Again, 1 to 2, 1 to 3, 2 to 3, and then we calculate a deviation. When it's done with the resistance test, we'll step right on into an insulation resistance test. There we go. Our resistances are all obtained, our deviation is calculated, and we've automatically run into the mega test. So this is a 60-second megohm test per IEEE 43. At the end of this test, it's going to do a surge test, so we'll have to stay on our toes to see that happen. Okay, we're about to conclude the mega test. Done. Now we're going to do a surge test on the stator. Now, surge testing a stator is actually pretty easy. You actually only need to put or apply 3 pulses to the stator. 1 pulse between lead 1 and 2, a second pulse between 2 and 3, and a third one between 3 and 1. Once it has those 3 waveforms, it will calculate the line-to-line or phase-to-phase error area ratio between the first waveform and the one between 3 to 1. So in this 3.7%, that's the error area ratio between the waveforms obtained between testing between leads 1 and 2 and between 3 and 1. The 4.6% are the 2 waveforms obtained between testing 1 to 2 and 2 to 3. And this 2.6% is the comparison of the waveforms between testing 2 to 3 and 3 to 1. So we don't actually have the waveforms in front of us right now. We'll go look at them in a moment. But we're getting the quantitative measure of the difference between those shape of those 3 waveforms. The 3.7, the 4.6, and 2.6. Before we get too far away, let's save the data. I'll press the Save to Memory button. Data is saved. Let's back out of this screen and go look at our waveforms. There we go. We actually have 3 waveforms right on top of each other. As a result, of course, being they're so similar, they have very low EAR values. Had there been a problem with the stator, like a bolted or welded fault or even an arcing fault, we'd have seen a shift to the left in the waveform. Now, this test was performed very differently than other testers in the industry. We just used 3 pulses at our recommended test voltage of 2,000 volts. We didn't have to ramp up. We got right to where we needed to go and identified the problem. Oh, we didn't find one here. That's very good. When we test the stator by itself, we can manually operate the tester. Here we can see by moving the whiz wheel back and forth, I can change the test voltage. Now, it's not going to let me exceed 2,000 volts, which is the recommended voltage for testing a 480 volt binding. Let me get you in there so you can see. Here you can see by moving the knob we can change voltage up to 2,000 volts. So let's just press the start button and do a test. You can see it's applying the test at 1525 there. I can ramp up the voltage with the knob while it's in this mode. And there's a test at 1650. 1800 volts. 1900 volts. And finally 2000 volts. So even though this instrument in its automatic mode behaves differently than other testers out there, we still have the same kind of ability to do what you've done in the past. Press the stop test button to finish. So in a motor shop setting, often we don't want to run a full automatic test. We just want to run a surge test after we installed some coils, and just run, say, a DC high pot test. We don't want to do a fully automatic test. To do that, what we'll do here is I'll use the whiz wheel to select the, say, the surge test. And we've got control of the knob voltage here. So I'm going to take the voltage down to 500 volts. And press the test button. So it's applied 3 pulses to leads 1, 2, and 3, and we're getting our 3 different waveforms and calculating the phase-to-phase error area ratios. Now it's in this mode. I can ramp up the voltage by hand. So this is very similar to what we've done in the past. So 1000 volts, I'll increase it to 1200. There we go. I'll increase it to 1300. There we go. Again, the waveforms are all sticking together, so there's no problem with this particular stator. 1500 volts. 1600 volts. 1700 volts, 1800 volts, 1900 volts, and finally 2000 volts. And I'll press the stop button to end the test. So here what we've done, we've disconnected our stator and just did a simple surge test on the windings. Let's back out of this and do a high potential test, a DC high pot test. Now when I press the start button, it's going to ramp the voltage up to a maximum of 2 kV, and we'll see our current displayed here. So here we go, start button. Ramped our voltage up to 2000 volts. Our indicated leakage current is 60 nanoamps, very low. This is well under a 1/10 of a microamp, so this insulation system is in good shape. To stop the test, press the stop button. So just to review, even though we have this automatic test capability that we showed earlier, we can still use this instrument much like you have in the past in the motor shop. Go direct to doing a DC high pot test, go direct to doing a surge test, and even if you want, we can go directly and running a resistance test. I'll just do that here. Select resistance, get the numbers, press the button. There you go, got 1 to 2. 1 to 3. And 2 to 3. So again, we can still run this test in a very normal mode that what you've been used to using in a motor shop, but we get the added capability of a little bit of automatic control to this, controlling our test voltages and a little bit of the test sequence. We get very accurate, reproducible, and repeatable results. Here we're going to show how to use the separate high voltage test lead on a Schleich MA2. This extra test lead will allow us to make DC high pot tests above the 3 kV limit of the normal relay matrix in the unit. So just a reminder, here on the MA2 there are 8 test leads total. 2 for motor lead 1, 2 for motor lead 2, 2 for motor lead 3. This yellow one here is a ground. You can see it's over here on the frame of the stator. Then there's this separate red high voltage lead, and that's what we're going to be talking about today. So on the stator, what we'll do first is disconnect our normal 3-phase matrix test leads, and we'll disconnect our single high voltage red lead here. Now, as a demonstration that we're actually getting the voltage, I'm going to set up a voltage divider here, and we'll look at the voltage over here. Now that we have our high voltage test lead connected, as you see there on the left, let's zoom in on the screen and I'll show you what I'm doing to select the this extra high voltage lead. So let's select a test mode of just testing a stator, which you can see there on the upper right side of the screen. We'll select that. It will ask us what voltage we want to test, or what the motor voltage is. Let's max it out at 690, and we'll select that. Now that 690 has automatically selected specific test voltages for doing the high voltage DC test, or a high pot test. So let's use the whiz wheel to select the high potential item. Select it. Now you can see in the upper right hand corner it's saying that we're connected to the matrix at the moment. Let's change that. Let's press the menu button. Use the whiz wheel to select the terminals. Let's change it to probe. And now we have the separate high voltage test lead probe selected. Now you can also see here that the voltage has been already determined to 2400 volts. Let's save that. And let's start performing some testing. So I'm going to back out so you can see the display of the DVM, and we'll run the test. Now you can see it automatically went up to the 2400 volts that was programmed, but you can also change the voltage with the control wheel or the whiz wheel. So you can see here on the display there's a little bar underneath another green bar for the voltage display, and that goes up and down as you bring the voltage up and down. I'll stop this. Now you can see there that it discharged the ground wall capacitance, and we're back to where we started. Now what I can do on this screen is actually, before I begin the test, control the voltage at which it starts at. So let's set it for, say, 400 volts. I'll start the test, and it automatically goes to 400 volts. And then I can control the voltage up and go a little higher. But notice it's not going to let me go past 2400 volts. I can spin this wheel all I want, but I'm not going to be able to go past. Let's stop that test. Again, you'll watch it discharge. While it's discharging, you'll hear a little buzzer that the instrument has making a sound just to indicate that it's discharging the windings. So we've shown how to do a DC high pot test with the separate test leads, and we did that in what we call the basic mode of the tester. In the upper left-hand corner, you can see that we're in the basic mode. That comes from just coming up to our test mode, selecting a stator, entering a voltage here, and going down to the options we want to work with. You can see it's basic over there. There's something called an expert mode. Let's look at that. In the expert mode, we can set whatever voltage we want on the test leads on this high voltage separate lead. So on the right hand side here, you can see there's an expert mode option. Let's select that. Once we're there, we can come down to the high potential test, press the menu item, and notice here we can select the maximum test voltage we want to go to. Let's set it high. Let's go nuts here. Let's go to 4 kV. I think this little stator will handle that, but let's find out. Now I'm going to start it down low to begin with. Start the test. Ramp the voltage up. And you can see there on the left-hand side of the video that there's a voltmeter showing the voltage that's actually being impressed on the machine. It's saying 818 volts. The MA2 is saying 804. That's pretty close. Let's continue to bring this up. 2600 volts. Let's go to 3000. Working pretty good. All the way to 4000. So of course, let me stop the test. The reason we want to do this, at least in a motor shop environment, is to, once we put a winding in and want to do a quick ground wall test to make sure that we haven't damaged any slot liners or anything like that, we would use this kind of testing to go to a higher voltage than our normal matrix would allow us to go to.